And now we're going to cap this kind of opening part of the symposium with a presentation by Dr. John Agnew. John has been a longtime distinguished professor of geography at the University of California, Los Angeles, with a particular interest in political geography and international political economy. He was at the Maxwell School at Syracuse University before that. We're going to hear more about John tomorrow because John is receiving one of the AGS medals, so you'll hear a lot more about him tomorrow, so I want to keep this very brief. But I just want to say, as a sort of longtime friend and collaborator of mine and someone for whom I have great respect, that it's really hard to think of anyone who's had more of a wide-ranging influence on the field of political geography over the past generation than John. His work on everything from place-based influences on politics to nationalism and borders, and even to the geography of water has been truly influential. It's that last theme that he's going to address this afternoon with us. So without further ado, John Agnew.
Okay, thanks, Alec, for that introduction. I'm very happy to be here. I've never been to one of these symposia before, but I think this is a really interesting and important topic. My theme is going to be a little bit more specific. It's going to look at the question of the governance of the supply of potable water or the access to potable water. And the first slide here gives you a sense of where I'm coming from. Anybody remember the 1974 film Chinatown? Anybody here seen that? You may be familiar with the question of why does the city of Los Angeles actually exist? Well, it exists because it's stolen water from other places. It doesn't provide enough water for itself in terms of groundwater or capturing the rainfall that does now and again occur in the Los Angeles basin. Chinatown, the film was all about the Owens Valley conflict and the role of famous Los Angelino Mulholland, who was the engineer. And of course, you may also be familiar with his name because he's one of the most famous streets in Los Angeles is named after him. Mulholland Drive, anyone? Another film, of course, endless films associated with Los Angeles. And he was the water engineer associated with capturing the water from Owens Valley up in Central California and then bringing it down to supply the city of Los Angeles. And today, of course, most of the water for Los Angeles either comes from Northern California or from the Colorado River. And as you may be well aware, the Colorado River now is, or since 2000, has dropped about 20% in its regular flow. And about half of that is due to removals, because of all the people living in Phoenix and other places that also draw from the Colorado River. But half of it is down to declining precipitation and increasing temperatures. So I just wanted to kind of bring this up at the beginning just to give you a sense that this is a topic of historic importance and one that relates to the United States as well as to more exotic parts of the world, as we've been listening to. And of course, some of you are probably aware that before the latest rainfall, New York City was under a drought warning. Anyone noticed that recently because of the low level of reservoirs in the Hudson Valley? So the world water problem then is something that we're all kind of intimately familiar with. I've only got 20 minutes or so. I'm used to speaking for like an hour, to a captured body of students. So I have to kind of squeeze a lot of material in here. There's an English phrase which is called over-egging the pudding, which I've been accused of on a number of occasions, which may well be the case here today. Well, I wanted to go through really 4 topics, each, of course, very, very briefly. The first is the world water problem, which has been announced by a number of people as being the great problem of the 21st century, I should hasten to add. Although listening to politicians worldwide, you would have no idea that this is actually the case. Anyone hear anything about water during the recent presidential election campaign in the United States? I certainly didn't, and I was looking to hear about it. But access to potable water is for the world's growing population and increased consumption from that and new uses. Think of things like data centers, data center servers that require vast amounts of water to cool them. So new uses and increasing amounts of use with all uses. So I want to talk a bit about that, and then I'm going to talk about climate change and the geography of water stress and sustainability. And then a little bit about which the previous speakers were addressing, the tendency to see the challenge in this particular area as irreversible and zero-sum, with water and climate as independent forces. If you've got water, you're lucky. If you don't, you're unlucky. When in actual fact, of course, as we know, and the LA case is a very good one, many places get their water from somewhere else rather than just locally. And then finally, what can be done? The management is a political problem, and thinking about the problem geographically rather than the way we often do. It's one of geographic scale. It's about kind of matching people where they are to where the water is available. Matching jurisdictions to management, this is a huge problem. In American West, for example, a drainage basin would be a much better unit to use than the states that we actually have. Moving beyond water per se to look at patterns of urbanization and water uses. Maybe many people are living in the wrong places, relative to the future of access to potable water. These are some of the questions anyway I want to raise. I don't necessarily have all the answers, but I certainly, I think, have some of the questions. So let's move into this. The world water problem, to start with. As with emissions reductions, resolving the world water problem in the face of climate change will require many small steps. This is my view. There's no sudden, complete solution to this. We're going to have to start with small steps rather than some sudden total solution or giving up entirely, which at the moment seems to be kind of more the strategy. It's a political as well as an environmental problem, and this was the burden of a speech I gave 14 years ago as my AAG presidential address, and I'm revisiting it today. It requires responses that are not just national scale, but require political cooperation across a range of geographic scales. And it's not that the Earth's water is in imminent danger of being used up. It's a question of matching availability of potable water to where people live. And there are really three dimensions of the current problem with massive geographical variation in use, access, and water quality. Let's take a first look at water stress. This is the numbers of the world's population as of 2019 and then 2050 who are facing water stress. That means depletion of the actual water that they currently rely on. And in terms of 80% water depleted, we're talking currently more or less about 2.2 billion people. By 2050, which is the year that this conference is organized around, that won't increase that much, perhaps, 2.8 billion. But when we add in the other 1.3 billion with high risk, we're talking about probably close to half of the world's population is faced with a risk of stress in access to potable water. That's water that can be used for agriculture or for everyday uses that we all require. And you can see this is the 25 countries that are currently exposed to extremely high water stress annually. You can see where they're located. It's overwhelmingly in what we conventionally think of as the Mediterranean world, North Africa, the Middle East, and South Asia. These are the places with the most serious, in terms of estimates of current highest water stress. In terms of water sustainability, global access to water services showing major shortfalls. You can see here this map's somewhat different. And this is people using at least basic drinking water services as a percentage of the population. So the water stress is much more concentrated in that belt that I just referred to. But there are many parts of the world where people have never had really adequate access to potable water. And this is particularly the case in rural Africa, as you can see from this map, in terms of the percent of the population in 2020 having low access to any kind of water services whatsoever. So that's where people are particularly vulnerable then in terms of having any kind of access at all, notwithstanding the question of water stress in the future in terms of climate change. So I think that's really very important. So given projected population growth, as many of you probably know, Africa has the world's highest rate of population growth. This is going to be the place with the largest shortfall. Sectoral demand for water varies. This is water demand as projected in terms of what I was just saying. 20 to 25% globally by 2050, with sub-Saharan Africa expected to skyrocket, you can see here. This is going to be a huge shortage of access to water. Now, in the African cases, I was pointing out, it's not just about the availability of water, but the access to the distribution of water. The lack of water infrastructure is the challenge. And that means, in fact, then encouraging the construction of better infrastructure in urban areas, and in rural areas, increasing access to supply of groundwater, which is often present in many of those places, but currently there is no access. Sectoral demand for water varies enormously across the world. So you can't just have one policy that fits everywhere. You know, you can't just say, well, we're going to have a world solution to this particular crisis, and that's a real problem because in Africa most of the use is domestic. That means household use. Industrial use is concentrated much more, as you can see here, in the Northern Hemisphere. One of the other big problems is the quality of the infrastructure itself. As you can see here, this is drinking water losses from distribution systems. Countries like Ireland and Bulgaria lose somewhere between 50 and 60% of their water through leakage, through a lack of maintenance, lack of capital investment in water infrastructure. And as you can see here, even in the EU, the red or orange-colored areas here are places where the water is in a bad condition. That means that it's toxic or it has minerals in it and so on that don't meet state standards with the main pollution source. And in California, quite famously, another movie, some of you probably remember, a much more recent one, Erin Brockovich. Anyone remember that one from 2000 about the pollution of groundwater, in this case in California? And now, of course, we have all kinds of other worries about PFAS, microplastics, and things like this. These are, as opposed to arsenic and whatever, which seem like, whoa, that's not so serious. So you can see here that across California, many of the water systems do not meet state standards. That's the problem we have. So how climate change is going to make much of this worse. That's kind of the message here, because I've got no time left, apparently. I haven't been speaking for 20 minutes. No. I mean, anyway, multiple dimensions to the water problem that will be exacerbated by global climate change. Rivers, groundwater, reservoirs, distribution systems, all of these things are vulnerable to climate change. The reservoir example is a good one. I just said New York has got a bit of this problem at the moment, even New York City. The light-colored areas on here are world reservoir inflow conditions in 2023, and you can see the below and much below figures. The orange and yellows are more common across the world than are the reservoirs that are full or above the usual levels. So this is a serious, serious problem. U.S. has water stress. This is between 2005 and 60, assuming no climate change. okay? Just assuming no shift in temperature or evapotranspiration over the next, from 2005 to 60. You can see places that have got water stress. The far northeast, northern part of New England, the west, not surprisingly, and then Florida. I know different problems in these places. The water stress is not the same in all of these, and a lot of it has to do with the quality of distribution systems, like in Florida, for example, or a rising sea level, in a sense leading to inundation and the pollution of fresh water supplies by seawater. That's much more the problem in Florida. In the West, it's much more a question about drought. Well, you can see here, much more of the United States now suddenly appears on the water stress map if we assume continuation of current trends in warming and evapotranspiration. And in fact, much of the country is going to be under water stress by 2050, 2060. Well, how do we connect all this to views of politics in the face of climate change? Water, it just turned on the faucet. You know, I heard that in a famous weave recently by someone who will be nameless. Turn on the faucet, turn on the shower. Why should we control how the water comes out of a shower head, you know? Anyone, no one remembers that speech? Engineering will rescue us. Past fateful decisions that we're now stuck with, it's too late to do anything. Or national policies will fix it. Cloud seeding, long-distance pipelines, shipping water, you know, from Norway to England. You know, perhaps some of these things could help. But it's global, national, and local problem. It's not just any one of these. So it needs addressing cooperatively across these geographic scales with an emphasis on local and regional participation, given that that's often the scale at which these problems arise. It's not a national level question, it's a local and regional one. Now, national policies can help with that, but the management of the thing has to be done across scales. And coordinating water policies with ones relating to urbanization, population growth, and sectoral uses. Anyway, I give some references here that you could look at. By the way, anyone who wants a copy of this PowerPoint can just email me and I'll send it to you so you can look at it more at your leisure. Well, if management is a political geographical problem, then what do we do about it? Well, in fact, as I was just suggesting, it's not really always a national level problem. These are the projected GDP and water stress correlations for the world's top 15 largest GDPs by 2050. China, not such a big problem. India is going to have a very, very serious problem in terms of access to water over the next 40 years or so. But it's not really just a national problem, as we can see here. It's a regional and local one. Many parts of India don't actually have that high level of water stress, but other places have terribly high ones. You can see here, this is a better map for understanding what the problem actually is, instead of that national level one or that national graph that we were just looking at. We often look at data through the wrong end of the telescope. And people in rural areas are faced with much more serious problems in terms of access to potable water than is the case. This is for African countries. In Angola, for example, access to water in rural areas is terrible. I mean, you can see here, it's around maybe 22% of the population in rural areas has access to reliable potable water, whereas in urban areas, it's typically much better. In the US, we organize things, of course, by our states, but maybe the river basins and cooperation by or across the river basins, like the Colorado River Compact, for all its sins, going back to the 1930s, are a way of trying to manage the water stress problem better than thinking just in terms of some kind of national policy. You can see here, this is the drought intensity in the summer of 2021 was particularly bad in the American West. And so in the western part of the country, we have to start thinking about managing the water problem beyond just thinking about water. And this map tells us something. Where are people moving to? Which cities are growing, which are shrinking? And frankly, in terms of water stress and water sustainability, many of the people are moving to the wrong places. Everyone should be moving to the Midwest and to the Great Lakes Basin and not to the Southwest, certainly not to Arizona and not to much of Florida, okay? So these are some of the things that we have to bear in mind. These are my sources, just to show that this just wasn't all off the top of my head, including an excellent publication by one of the sponsors here of the climate, what's it called, the sponsor here? The Columbia Climate Institute, which was really good on the whole question of why America's water infrastructure is crumbling, which was published last year. So a whole bunch of interesting sources here. Thank you. Sorry for going on too long.
Thank you, John, and we look forward very much to recognizing your outstanding work tomorrow at the Honors and Awards ceremony.
Thank you.